Welcome, everyone. So I'm excited to introduce the Vault file system today. And it's been several years in development. I'm going to give you a little brief background about how Swiss Vault started on this project. So many years ago, I was working also at Novartis to sequence the genome of cancer cells to understand the mutations that drive cancer cells. And we were very successful identifying these mutations that drive the cancer cells, but we were left with another problem. Each cancer sample we sequenced generated 1 terabyte of raw data. And within a few months, we were buying more data storage capacity just to manage the output. And since your genetic data stays with you for your lifetime, we're wondering, well, we have this genetic test and this healthcare data that's very valuable. How do we help the patients keep it for decades, for their lifetime? Since the genetic data is also your most private data, we're also stuck with the problem, how do we keep this secure for that lifetime? And so when we were grappling with these questions, this is how Swiss Vault was founded, to solve the problem of economically managing large volumes of data for decades with security and privacy. And that's basically forms our mission statement. Our mission statement is to provide organizations with technology that combines hardware and software for economical, resilient, and environmentally sustainable data management. And what we soon learned was that the healthcare industry is not the only one that's facing a tsunami of data. Just about every industry, universities doing research, institutes working on particle physics, banking, entertainment, seismic, they're all struggling with how to store this growing volumes of data. And that's the first law of data. It's data will, just like entropy, will grow. And the global data sphere is at right now about 75 zettabytes. And the Seagate and IDC put out a white paper a couple of years ago that said that it will increase to 175 zettabytes by 2025. And that is an astronomically huge number. And it changes, and however, it changes in every industry that we're already seeing. Automation, self-driving cars, digital health, they're accelerating the growth of data. And COVID lockdowns is, for instance, in the last 2 years, with more people going online, are estimated to have accelerated that and jumped it by about 20 zettabytes just in 1 year. So not only do we need more space to store the data, we also need lots of energy. And currently 4% of the global energy production goes to data management. And this is really not a sustainable trend. And so we know that current rack or tape technologies cannot scale to meet the demand. And there's a very severe risk that a lot of the data that gets siloed because of these interoperable media where we want to stash the data away in a mad rush to store the data. So hopefully with Swiss Vault, we can provide you some solutions that might help you to solve these problems. So the customers and the people in the industries that we're working with right now are all the ones that are generating lots of data, but they're also capturing lots of data. They're capturing data and to run real-time, real-world analysis of meteorological problems, medical genomics, or even particle physics. And these data are in the petabytes, tens, if not hundreds of petabytes. And what the customers want, of course, is that they want to have high security for the data, but they want long-term storage and real rapid retrieval for analysis, so that their customers or their partners or their their employees can make actually sense of the data to get real insight. So Swiss Vault is trying to change the paradigm of how we store data. We have developed a software and a hardware solution. The software is our file management system. It's very unique, and we're going to present that today for the early access discussions. And the hardware is also very unique. It's also available for pilot testing, and it will be available in a few months, in fact. And the software and hardware are independent of each other. The software can be used with any hardware, like Dell, Lenovo, or HP, and the hardware can be used with any file system, file management system as well. So I want to give you a preview of why we're excited about the hardware. So we have designed a very novel form factor, which will significantly reduce the space for data storage. On the left-hand side, I'm showing you a conventional hyper-converged rack, which has both storage and compute, and has 2.5 petabytes of storage. But by our novel design, we're able to get 4 times more data storage in 1/3 the size, 10 petabytes by decreasing the size by 1/3, volume by 1/3. Thus, our data storage density has been increased dramatically. This will help organizations store more data. Look at the bottom part, 7,200 watts per petabyte for a standard rack, whereas our tower design is 1/10 of that energy. So using less infrastructure, less energy. So we can store more data with less energy, you also reduce the carbon footprint dramatically and the environmental impact for the data, which we're very excited about as well. So, but today we're going to talk about the Vault file system. And I want to talk about a little bit about the challenges that we see ahead for data storage industry. I think some of them will resonate with you. We can all agree that data storage is now a very critical strategy for all organizations. The job of a chief information officer or manager of the organization's data center has become even more complex year by year. They have to think about not only how do I store this data, but how do I make it accessible so that people in the organization can do more with this data, which is their valuable resource. How do you increase the storage capacity with a constant stream of new gadgets that are producing even more and more data? And how do I provide faster access? Because latency is also a problem. And above all, how do I provide security? Because data theft is a constant problem as well. And do this all within a limited budget that that data managers often get. So for most organizations, how they set up their data management strategy takes into consideration a number of performance criteria. What is how fast or slow do you want the data access? What is the price of the equipment and the volume of the data? And all of these have trade-offs. What we show at the top of the pyramid is that one needs very fast processing data, like with stock market trades. And you have to use, so you end up using very expensive flash drives. Thus, low quantities of data are usually stored at the top part of the premium storage capacity of this pyramid. As you go down the pyramid, the volume of data to manage increases dramatically. We're now at tens to hundreds of petabytes. At the bottom, organizations are typically using tape drives, which are cold or dead storage. At the top, we need fast access data. On the bottom, we're trying to trade off speed just to keep our costs down. And when we look at the Vault file system, which we present today, we're really focused on the middle tier there, warm storage, where you can get access to data, you can store large volumes of it, and basically be able to get real-time access as well as if you need the access to archive data. And what I want to be able to discuss with you, perhaps demonstrate during the early access program, is that we might be able to help organizations achieve efficient archive storage, potentially replacing the need for tape at your organization entirely. So I would be remiss if I didn't mention that there are always new paradigms coming out to help organizations develop more efficient ways to manage data and get more out of the data. And I'm a firm believer that simple solutions are more elegant. And but here I show you some of the emerging solutions on the Gartner hype cycle that help organizations manage data. And this year, 2022, we have a number of things that have been highlighted by the Gartner hype cycle. One is the computational storage, industry cloud platforms, and cloud data ecosystem, and cloud sustainability. I think the real struggle is that as long as data volumes continue to grow, we need more efficient ways to capture and store the efficient and run analysis of that data. And none of these are addressed by some of the technologies that we're showing here. And we'll get back to that in a question. I just want to mention that in passing. So as I said, we believe in simple systems, and we use a simplest use case to map the data management bottlenecks that we are working to solve. In the simplest case, most organizations will attach their client applications to fetch data from a storage system. And the storage system is usually disk arrays for data that need to remain accessible for analysis, and/or tape drives. The data on tape drive is obviously not accessible for easy analysis. This data has to be migrated to warm storage servers before it's accessible again. And because of the growth of data outstrips the resources of usually every organization, most organizations will turn to some sort of co-location service or cloud organization to manage the data. And that's just basically outsourcing the workload to someone else. But the following problems will always remain the same. The first problem is that, as I mentioned, the natural law of data is that it only grows exponentially. And in fact, when you start out with a strategy to manage certain amount of data, just like entropy, people working on the data create new insights and they create more data. Ever increasing next generation machines are producing higher volumes of data. So the data in any organization will continue to grow, and you have to be able to manage that somehow. So one will need more servers, tape drives, more data center space, and more energy and people to manage the equipment, and you got to be able to budget that. The second problem is that servers and tape drives don't last forever. So that's organizations usually implement some sort of regular data migration to circumvent sort of failure rates or drop-off failure rates. For disk servers, that's usually a 3 to 5 year cycle. And for tape trail systems, that's every 7 years. And if you outsource your data to a cloud or cloud operators, they have to do the exact same thing. They have to migrate your data on their site to some other systems. It's quite a bit of an undertaking and obviously drives up the cost and strain on most organizations that try to manage data in-house. The problem number 3 is cost. While data is growing to zettabytes, the cost for a gigabyte of storage has almost leveled out since 2011. And as a result, you're trying the difference in the growth of data and the cost there for disk storage has to be leveraged by maybe finding other more efficient solutions, decreasing your energy, decreasing your overheads, etc. So for these 3 problems, the vault file system can be of immediate benefit. For problem number 1, where data continues to grow, the vault file system helps you use the same server equipment, but store more data on it, just like I showed you earlier. And then we're going to demonstrate that in the next couple of slides. And problem number 2, where you have a replacement of equipment cycles, what we're trying to emphasize and change the paradigm is that the vault file system, you can use those disks under the end of their life, maximizing their use. And problem number 3, which is that costs are increasing, taken together with the benefits of VFS, because all the operations are automated, VFS can reduce the overall costs. I would love to show you that by doing a study with you, perhaps. And with that introduction, I'm going to invite Mehmet to present on the vault file system.
Okay, thank you. We discussed about the problem and how we address it. And now we will learn about our software solution. Before we deep dive into our software solution, I would like to talk about a few concepts to make things clear for everybody. So probably everybody knows RAID systems, but let's remember, think that you have 1 terabyte data and you want double redundancy, 2 redundancy. So you have to sacrifice 2 terabytes of your available data to have this redundancy. And yeah, having 2 redundancy is something good, but there are some disadvantages of using RAID system. So as I mentioned before, your overhead is high in this case, and it's not distributed throughout the nodes. For example, if you lose your node, you lose your data. And if you lose even your RAID controller, you lose your data. And you don't really have control over your storage overhead. And our alternative to RAID system is erasure coding. So user transfer data to our file system. We get the data, we chop it into the number of segments and calculate the parity and store those segments to different nodes and to different media. So this is the basic 4+1 example. 4+1 means 4 data segment, 1 parity segment. So after we transfer our data, we expect to have problems, right? We can have bit rots, we can lose a disk, or we can lose a node. So what happens? We gather all the available pieces and calculate the missing data and bring them together and give it to user. And this encoding and decoding operation occurs on the fly. So user doesn't even recognize that they lose their node or media, or they have a bit rot in their file. So as I mentioned before, yeah, we have a huge overhead on RAID systems. And we discussed about some disadvantages of RAID. So what we can do. So let's think about having a vault file system configured as 8+4, so 8D and 4P. This gives us 4 redundancy with only 50% overhead. And it's very flexible. You can set anything. You can set 100D and 5P. So you can have 5 redundancy, you can lose 5 media, but you only sacrifice 5% of your available storage. And this flexibility gives you the ability to estimate your cost. And you can also configure your redundancy, and it's configurable per folder, per user, so you can change this parameter dynamically, and you don't have to stick with the single configuration as RAID systems. So our purpose is to have a long-term solution, long-term storage solution. So what we do for this, we have Azure coding, and it's configurable. As I mentioned, it's dynamically configurable, and you can define your data storage strategy. You can define your redundancy. You can define your cost, which is your storage overhead, and your data is distributed and erasure coded. So you are redundant, and your data is distributed through the network, throughout all the nodes you have, and it's flexible, and you can add nodes on the fly dynamically, and it's easily scalable. So you define a system, and then you can reconfigure it on the fly. So you can change your strategy. You can analyze your data that is coming to your system, and you can redefine your strategy. And metadata is also distributed and replicated. So what's metadata? Metadata is the data about your data. Every file system has a metadata, and metadata knows how to bring these bits and bytes together to give you the exact file. So it's very important. If you lose your metadata, even if you have the data, you don't know how to bring it together. So in our system, it's distributed through the nodes, and it's replicated. And as we see, we use erasure coding, and we detect bit routes, missing chunks, missing media, missing nodes, and we detect and correct them on the fly without users cannot even understand that they lose something, they have a problem. In addition to on-the-fly correction, we also have an automated regeneration functionality that runs in the background. So let's say you lose a media, your user can still have access to data without noticing that something is wrong there. But once you lose one media, you went down to 4 parity. It was 5 before. When you lose one, you went down to 4. And we don't want to lose all of our media in time. So that's why when the system is idle, we regenerate all the segments that's stored on this media to somewhere else to keep the parity level at the set point. And our system is also peer-to-peer. So there is no single point of failure in our system. We don't have a master node. All of our nodes are equal. They serve, they do the same services. They do the same functionality. So it doesn't matter which node you lose. It doesn't matter which media you lose. Your system is still available. We have a video to show you how VFS works. So we used an ordinary laptop and USB sticks to keep it simple and show the flexibility of the file system. And in this video, you will see that we intentionally unplug some USB sticks to demonstrate loss of segments and how we correct it on the fly.
Welcome to our Vault File System webinar. In this video, we will demonstrate the capability of the Vault file system and its flexible data and parity options. Here, we configured VFS for 2D plus 1P and 10D plus 5P. For the purposes of the demonstration, we are using lowly 32 GB of USB 2 drives. Note that USB 2 drives are not individually capable of playing back 3 simultaneous videos. But by running them in parallel, we obtain the sufficient speed. The Vault file system will work with all hard drives, solid-state drives, and flash drives. Here's the 2D plus 1P demonstration. We start with no drive installed. The Vault file system or VFS mount location has unknown free space. Let's install drive number 1. VFS mount location has 31.2 GB of free space. Drives number 2 and number 3 are also installed. VFS mount location now has 93.5 GB of free space. Let's copy 3 video files to the Vault file system. Once the copy has completed, we will demonstrate the robustness of Vault file system's data correction. While running 3 videos, we will simulate a failure by removing a drive. As 1P is configured, the loss of a single drive is handled. However, the removal of an additional drive will cause VFS to declare an error and the videos will stop. Since VFS is configured 2D plus 1P, the data is not available while more than 1P media are missing. Here, we reinstall drive number 1.
As you can see, we just need to wait for a few seconds for laptop
Once one
to
of the missing
recognize
drives is
new
back
USB
online,
stick.
the videos will resume. Let's try again by removing drive number 3. As expected, the videos stopped playing since 2 drives are missing. Now let's reinstall drive number 2. With VFS, it doesn't matter which drive is corrupted or removed. What matters is to have the number of D drives available. Here, that is 2 drives. Now for the 10D plus 5P demonstration. Here, 15 drives are installed. Again, we will test VFS's data correction by playing 3 videos. 5P, or 5 parity drives, means tolerance of up to 5 media failure, extremely unlikely in practice. Any 5 drives are removed. As expected in 10D plus 5P, the videos are still playing. However, when one more drive is removed, the playback is prevented due to having insufficient media. Once any drive is reinstalled, and at any location, the videos will resume playing because VFS has enough drives to rebuild their data from. Let's retry with another drive. Any file can have any D+P, allowing complete robustness and overhead flexibility. The high parity ability of VFS allows running media to the point of failure without actually affecting access to data. The operation of the media beyond its failure and being able to wait for scheduled maintenance to replace media means that the total cost of ownership is minimized without sacrificing data availability. Thank you for your participation. Feel free to ask us any questions.
What I'd like to open up for is a little bit of discussion about the open access program. But before I mentioned, in that video, we wanted to be able to capture a lot of the nuances of how the VFS works. A single USB 2.0 drive would never be able to play multiple videos at the same time. And because it's just not possible. But what we've done is now the VFS, Vault File System, actually enables us to do this parallelization, so we can access data at much faster rates, even for very small capacity USB 2.0 drives. And I think that's the magic of the VFS, is that we can get higher performance out of very low performance systems. So our early access program is basically opening up for select partners. We've already had significant discussions with a number of partners, and we decided to reach out to some of our community members and to have a discussion about this and expose more. And also we're looking for value-added partnerships as well through this program. And so what does that actually entail? Well, what we're looking for are our partners who have a use case. And what we provide, of course, is the software to run on your systems, or you can use it on our systems as well. So just if you wanted to play with it. And we provide all the other tools that you can use to get graphical information about your performance of the system, or understanding the system performance. And we, of course, do the full support for integration of this onto your platform if you need to. But what you need to provide, if you want to do an on-site test, is basically a system that runs Linux operating system, optimally 3 nodes or 3 nodes with servers, 1, 2, 3 disks in each of those nodes or servers would be optimal. And networking, any speed networking. If you have bulk data that you can play with, that's also optimal. But critically, you need time availability to help you run your use case. So that's what we're looking for, and we can open that up for discussion. And what I wanted to mention again, as mentioned earlier, if you are interested to run this Vault File System in the early access program, you can contact Joe Suppers or Frederick Schmiller. I'll leave their emails up here while we open up for a Q&A. So with that, I'd like to open up for Q&A. And I think there's some questions coming already in the chat.
Yes, so I see one question already in the question box. Do all the drives need to be on the same computer?
No, it doesn't matter actually. They just need to be in the same network. They can be on different nodes, different geolocations. They just need access to data.
How can I transfer data? Can I use standard Linux commands?
Since our file system is POSIX compliant, it supports all the POSIX commands. I mean, you can just, as you see, you can just right-click and copy and paste it to copying to a USB drive or to a folder in your hard drive. And you can use other tools like rsync, SCP to transfer it. And Well, we recommend to use our native client application to get access to Vault file system, but it's also possible to use NFS or Samba to have access to it. So yeah, it supports Linux commands.
What happens when I run out of free space?
If you run out of free space, it's always an option to add a new media. If you have a free slot on your servers, you can also add another server to the cluster, so that you can add it dynamically. You just need to deploy Vault file system on it and connect it to the network, and it will be recognized by the cluster, and you will have extra space in it. So it's scalable.
What is the software install time?
It depends, actually. For example, if you have a built server running in your network to boot all of your servers using Pixie boot through the network, then you just need to deploy it on your build server, and then you just power up your servers, and it will be system will be up and running, and all the media on all of those servers will be available for your use case. It takes about 15 minutes to deploy, to install some libraries and to deploy it, to configure it. And well, if you don't have a built server, then it is 15 minutes times number of servers you have.
Thank you. How do hardware updates work?
For VFS, we keep track of the media using a unique ID that goes with the hard drive. So you can just unplug the hard drives from one server and plug them to another server and run the Vault file system. Then this VFS application will recognize, using this ID, recognize the media, and will bring them, add them into the cluster. So in this case, you just updated your server if you need to, and it is also, as you can see, it's very flexible. There's no there's no theoretical limit, actually. So you can unplug. If you have a failed hard drive, you can just unplug it and install an SSD. So now you updated your system to SSD. And it doesn't have to be failed. If you want to replace your system with your hard drives with SSDs, you can basically just remove the hard drives, which is number of hard drives which is less than P configuration, so your data still will be available. Then you can install SSDs to the same slots, and the system will recognize and move the missing media to those SSDs. Now you updated your hardware to faster system.
Is there a software subscription model?
The correct answer to that is yes, it is a subscription model. And the reason is because we have a huge vision for what we are trying to unveil. We have lots of features, and I think that we'll be able to release them over time. And I think it'll be a higher value for our partners and customers. So I think yes, the answer is yes, and we're working on that model.
Thank you. How is new media added to the VFS?
If you have available slots on your servers, you will just install a media there, and then using vman tool, you will tell the file system that, hey, I have a new media and you can use it. And then it will be added to our cluster.
Another question, could we test the system on your servers or must we download it on our servers?
So we are working to set up we already have an internal setup for an environment where you can have access to run it on our servers. So that's quite fine. But we're also working with one of our partners to set up a test environment that will be a bit more of a higher performance environment, but maybe also multiple different media types. And you can test it on that environment as well. So we're working on a number of options, but if you're interested, just get in touch with us and we'll give you one or two options if you wanted to test it on our environment. And yeah.
Thank you. When will the hardware be ready?
We are working on a release cycle of Q1 for the first pilot testing with it. But again, we've already selected the pilot customers for that phase. And then Q2, we'll do a wider pilot for the hardware. And I think then we'll do a similar webinar like we're doing now to our community and try to get to discuss then at that point. So, but basically about Q2, Q1 is already taken up. Q2 probably when we do the wider release.
How would you go about testing and validation? Testing and validation, sorry.
Well, I mean, I think both Em and I can answer that question. Yep. We do have kind of a manual for the sort of the early evaluation phase, where we describe what the features are and how you can run through the paces so you can validate them for yourself. And then we'll work with you, as I said, from our side team to help you run any kind of use case that you may have on site. But most use cases will probably be applicable for just the archival storage application that we're releasing the first version for. Emmett, do you want to add something?
Yeah, that's it. So yeah, as you mentioned, we have a procedure. And we are also expecting our testers to come up with their use cases. So, we have a standard template. We are using standard tools to benchmark our file system. And we have sample data to exercise the file system. But as I said, as everybody knows, there are lots of different applications and lots of different use cases. So it would be good to have their idea.
How long will this test last, the pilot test, and will there be support provided during it?
We are in a discussion with genomics industry, so their data is huge. So they may want to exercise the file system and the availability of the file system using their data. Of course, it will take some time. So it depends.
What is the acquisition cost of software and hardware?
Okay, maybe I can take this question. So basically, we have we see a way to disrupt the general paradigm of how storage is done so that we can enable customers to have more value. So in the discussion with the early pilot phase customers, we're looking at how we can provide hardware as a service and software as a service. And it enables you to scale out as much as you need or scale down as much as you need. And so for this, the acquisition costs are probably on a kind of on a licenses basis and a leasing basis. So we're looking at typically about 1 cent per gigabyte per month. It could be about 2 cents per gigabyte per month, basically, if you're looking at hardware and software combined. And so from there, you can make some calculations.
What is the processing requirement for the VFS to reduce the data footprint?
To reduce the data footprint, as we discussed during the presentation, it's D+P strategy is configurable. So you can keep the ratio of P low so that your overhead will be low.
Do you have any ideal specific data types?
No. So it's as I said, it's POSIX compliant. You can store any type of data to the file system. And yeah, there's no limitation there.
Let's see. Will you be scheduling a deeper dive into the software on another webinar for their tech team?
We can also do that on an ad hoc one-to-one basis. Obviously, anyone's expressing interest in the early access program, we will work with you directly to answer any questions about what your needs are and what you would like to do. We're doing that with a telecom company. We're doing that also with some universities as well. And so if you're interested, just come talk to us and we'll do a deep dive as you need.
March timeframe is the deliverability timeframe. Yes, thank you.
No, this is the pilot testing timeframe. We're going to go commercial launch probably towards the end of the year. So it's we for hardware, we envision a little bit longer cycles just because it's hardware, and so we have to deliver that hardware to a partner site. There's going to probably be a longer cycle of testing and validation, and we also have a different sort of a workflow to get it out to the commercial launch. So it takes a little bit longer in overall for hardware, unlike software.
Thank you. And then this one's connected to your previous answer, so I would just ask it, the last one. What is the ideal use case for the VFS software?
We designed our solution to solve the problems that you have if you need a long-term storage. So we don't focus on performance. We focus on long-term storage. We focus on redundancy. We focus on having low storage overhead. So I can say you can think it as an online tape replacement, or you can think that it's a solution that you can run in-house, and still your availability will be as high as the data centers. So our main focus is to have long-term storage, keep your data for decades.
I just see one last question. So if anyone has any more, please send them our way now, and then we can close the Q&A. How do you add more space to VFS?
It's possible to run new nodes, bring new nodes to add new nodes to cluster, add new media, and it's also possible to play with your D+P configuration. So let's say you have 10D plus 5P, and later on you run out of space and you need more space. You can change it 10D plus 3P. If you are okay with the 3 redundancy, then you will have extra space on the same hardware. And also, and also, as we mentioned, the disadvantages while talking about disadvantages of the RAID, you don't need to copy your data to another storage systems.
Thank you. And that was the last question I saw in the Q&A box. So I thank you for your questions, and Bhupinder, back to you.
Okay, well, it's been a pleasure holding this webinar, and I think we're going to do many more in the very near future on the different topics that we have, because obviously there's many more things that we haven't even discussed about, especially about the VFS. And so thank you for all your questions. And also, I reiterate that, and also joining this webinar on VFS. If you have additional questions or would like to inquire about the early access program, you can write to Joe and Frederick, whose emails are on the site. And as I mentioned, please keep abreast of this channel, because we'll be launching more webinars in the near future. And so thank you very much. And I wish you all a great day and a great week ahead.
Thank you, everyone.
Thank you, everyone.